Okay, so 30 minutes. I try not to make it last any longer than 30 minutes. A lot of that'll depend on you guys. So all I want you to do, and all you need to do for 4 points, so if you do nothing else, 4 points is what you'll get. Just answer some questions. Just participate, okay? So what we're talking about today is some rational functions. And why should we learn this? Because rational functions are used to solve many problems in the business world. And we kind of, no, it wasn't in this class, it was in my Core 2 class that we did some rational functions when we were talking about paying people. We have X amount of dollars to pay X amount of people, and how much can we pay them? That is a rational function. So, real world examples, the average speed over a distance. Traffic engineers or civil engineers use that. Concentration of a mixture. Those are chemists. Average sales over time, sales managers, and the average cost over time are chief financial officers. So these are the reasons that we learn this stuff. So just, a little example. So first off, what is a rational number? Anybody? A rational number. Our numbers are divided into two types, irrational and rational. So Jenna, you're saying rational numbers are whole numbers. Anybody else?
A number that can be written as a ratio.
A ratio, exactly. Numbers that can be written as a ratio. So they're not just whole numbers, although those can be written as ratios, right? What's the ratio for 3? What's a 3 over 1? So that's the ratio, right? So give me another number that's a ratio. 1/2. One more. 7/10. Those are all rational numbers. All right, so it's a number that can be expressed as a fraction. And there's a bunch of them. They can also be decimals. So what is an irrational number? Just because we know what a rational number is, what is an irrational number? Or give me an example of an irrational number.
Pi.
Not just square roots, Jetta, because the square root of 25 is 5, right? Jordan's here and he's saying pi. Pi is an irrational number. Why? Goes on forever and it never repeats, right? So there is no pattern to it and it goes on forever. Okay, so it's a number that can't be expressed as just a fraction. Makes sense, right? Pi. Square root of 2 is an irrational number. Square root of 3 is an irrational number. Square root of any prime number is irrational. I guess maybe that's what you were thinking about, Jenna. All right, so a rational function comes or has the form of what? A rational function has the form of what? No, this is a function, not just a number, okay?
Oh.
10 divided by 3. No, this is a whole function. That would just be a number, John. That's good. What did you say in here?
Fraction.
Okay, it's not just a number. We're talking about a whole function. So what is important when you say function? What do you always know about that thing when you say it's called a function? It has what? It has one variable, exactly. So a rational function is where you have a polynomial divided by a polynomial. All right? Does that make sense? And think about the problems. I think everybody here has done at least the first problem or the first practice. And that's where you had, even if that polynomial is just a 2 or a 3, that's still a polynomial, right?
It is a polynomial.
Why is it a polynomial? What kind of polynomial?
Rational.
What kind of polynomial is just a 2? What's that called? Oh, okay, thanks, John. If you just have a 2, what kind of polynomial? That's a specific polynomial. It's called a one term monomial, right? One term monomial. Okay, so anyway, a rational function is some kind of function divided by a function. And the only restriction on this is that q of x, or this thing that it's being divided by, cannot equal what? 0. Boy, Jordan, you're quick today. So a parent function of, when we're thinking about rational functions, is this 1 over x. So the graph, and you guys were supposed to be graphing, I think, for the second practice. The graph for this 1 over x looks like this. Okay, there is a vertical asymptote at 0. And why is there a vertical asymptote at 0?
At 0. They never touch. They never touch 0.
Why is there a vertical asymptote at 0? What can that denominator never, ever, ever be? 0. So you take that denominator, set it equal to 0, and that's where you're going to find your vertical asymptotes. Okay? All right. It's not continuous because it has asymptotes. In this case, it has x and a vertical and a horizontal asymptote. Okay, so transformations, and this is what you were doing in your second practice again. You were moving these rational functions around. So here's my parent function again. All right, my vertical asymptote is at 0. My horizontal asymptote is at 0 too. Does anybody know why?
Because it can't be 0.
I'm talking about the horizontal. You're right about the vertical. But what about the horizontal? It can't be 0. Why?
0 does not divide.
I mean, it's 0. Why?
Because you can't divide by 0.
That's the vertical. I'm talking about the horizontal. Vertical asymptote, yes, it is at 0 because you cannot divide by 0. But the horizontal asymptote, and you're going to learn this because the numerator, the degree of the numerator is less than the degree of the denominator, and so your horizontal asymptote is at 0.
How do you know that?
Okay, so good question. Because the degree of a 1 or a 2 or a 3 is, what's that degree? How many variables are in there? Variables. That would be the letters. How many letters are in
Oh, 0.
that one on top? 0. So that means that the degree of this top, or the numerator, is 0. Okay, what about the degree of the denominator?
0.
What? It's 1. Exactly, because the exponent here is 1. So the degree of the numerator is 0. The degree of the denominator is 1. 0 is less than 1. So I know that my horizontal asymptote is at 0. Okay? And these are just rules. There's 3 rules for horizontal asymptotes. That's all you have to remember. All right. So we're going to talk about, how does this move? So what's going to happen if I have, this is my parent function. Now I want to move it to 1 over x plus 3. How's that going to move? Okay, Jordan says up 3. Anybody else? How is this function going to move? Up 3, over 3, to the right, left? I don't know. Tell me, how do you think it's going to move? Samantha says up 3. Anybody else? Jenna said up. Okay, anybody else? Okay, it is. It's going to move up 3 because of this number out here. This is, I always get this mixed up. This is where it moves up and down, okay? I always get these mixed up. This is how it moves up and down. If there were something down here, it would move left and right. Does that make sense? X, something with the X, it's going to move in the X direction. Outside here, it's going to move up or down. All right, so it's going to move up 3, and there you go. Again, here is your parent function, and here is your transformation. Make sense? Okay. And there, the yellow line right there is the horizontal asymptote. All right. So again, here's my parent function. How does this one move? I have 1 over x plus 3. How does this move? Up, down, left, right? Left, right. Okay, does anybody know left or right? Well, Jenna said right. 3. Okay, right 3. Okay, I gotta figure out which is my left and right. I always have issues with that. Anybody else want to give it a shot? We have one person that says right 3. And Jordan is saying left 3. Anybody else? I got a couple. Samantha says right 3. John says left 3. Okay. Jenna, what did you say? Somebody was typing here. To the right. Okay, so let's look. Whoa, which way did it move? To the left. Why is that? Remember, you can't divide by 0, right? So what you're going to do is you're going to take that denominator and you can set it equal to 0 and solve for x. So x cannot be -3. Denominator can't be 0. All right, so that's why it moved to the left. It moved to the left or to the negative side. All right, what about this horizontal asymptote? Why is it at 0? The degree in the top is 0, and on the bottom it's 1. So that means the numerator is less than the denominator, so the horizontal asymptote is 0. Okay, parent function. Oh, wait, sorry. Okay, there we go. So tell me, how is this going to move? Up, down, left, right. Jenna says right and down. What? Right and down? What do you say?
Down 4.
Down 4? Right 2, down 4, and that's what Samantha is saying. Ladies?
I agree.
Yes?
I like that statement.
Sure. Everyone's agreeing. Let's just see. There we go. It moved to the right 2 and then down 4. All right. So your assignments are basically just like that, okay? For assignment 2, that's all it is. Okay, whoa. I hope I didn't. Okay. So what about this one? How does this one move? Let's think about this. How does it move?
It's going to be what?
What do you mean 1 times
Or
1?
the bottom.
Is the bottom ever going to be 0? Is the denominator ever going to be 0? Think about it. Think about it. Is it ever going to be 0? Is the denominator ever going to be 0?
Yeah.
Really? What if x were 0? Then you would have a vertical asymptote at x equals 0. Does that make sense? Okay, what's happening here is the denominator ever going to be negative? If you square a negative number, what do you get? Positive. So, yeah. So what does that tell you?
That's very complicated.
Let's see. Is that complicated?
Yeah.
No.
A little bit.
All this is saying is, again, we have a horizontal asymptote, and again, remember, horizontal goes horizontally, right? Across the x-axis, right? And it's going to be 0 because numerator is less than denominator. And we have a vertical asymptote at 0 because x can't be 0. And the other thing is that what happens here is we're going to flip this part over here that's in the third quadrant, it just flips up to the second quadrant because it's never zero. It's never negative. Okay. Good. Let's talk a little bit more. Okay, what about this? What happened here? What did I do to this function? Okay, quit messing with my pointer. To make it this function.
It was negative.
What did I do to this function to make it this function?
There's a negative.
Is there?
I mean,
No, I don't think it's ever negative.
oh,
Okay, Jenna says
it's
1 over x squared plus 2. Anybody else?
I agree.
Jordan agrees. We'll go around the table. What do you think?
I agree.
All right. Okay. I don't know. Got a couple people thinking over here. Samantha's saying the same thing. Agree tentatively. You don't agree. Oh, but you should. Because remember, I know. Remember that this right here is your horizontal asymptote. So this is saying, okay, now it's not 0, it's going to move up 2. All right. What about this one?
You added.
What about this one? Oh, and we got, Jenna says 1 over x squared, and that's in the denominator. Is that right, Jenna?
You added a negative 3.
Okay.
Stop.
So you add a negative 3. Okay, good. Anybody else? Agree, disagree? Agree. 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 Why are you guys agreeing? Good, Samantha. I like the way you wrote that. Okay, so when you do this, just so you guys know, I guess I wasn't paying enough attention to Samantha's thing there. Yeah, the squared goes on the outside, so the whole thing on the bottom has got to be squared.
So wouldn't this be 9?
Wouldn't what be 9? Yeah, it would be x squared minus 6x plus 9. Okay, what about this one? Last one. What about this one?
You should let you added 2.
Added, it looks like 3 there.
Oh no, you added like a 4.
4?
You added 4. And then you did.
Oh, on the outside. Okay, I see that.
And then you did
Okay.
minus 2.
You just combine the two.
X minus 2 squared.
Okay, so we got something from John. I got something from Jenna. I got something from a couple of the people here. So let's look at this. Yeah, there you go. Okay, so you guys are getting pretty good with these transformation things. Yeah. Okay, now we're going to talk about domain and range. All right, so if we look at this function here, what is going to be the domain?
I don't know. There's no graph.
Nope, there's not a graph. First off, do you guys remember what is domain? What is domain?
Your X.
Good. X-axis, all the X values. Okay, so look at the denominator. Tell me, what is the domain?
The domain is -2 to infinity. Negative infinity.
Almost. Yes, John, good. The domain is all the real numbers except -2. Not just 2, but -2. Okay? Because it can't be -2. Why can't it be -2? What's going on at -2?
It'd be 0.
Plus -2 gives you 0.
So what is that called? That is correct. But what is that called on our graph? What is that called on our graph?
Excluded values.
Excluded values, but what is that called? That's got a name. What's the name? What did we just call it? What were we just looking for? Come on, guys. Not
What
the
does it start with?
x-intercept.
The domain.
Not, no, that is the domain, that's right, but what is it called on the graph? -2. What is -2 called on our graph?
A number.
Asymptote. Yes, it's called the asymptote. What did you say?
Asymptotes.
I didn't hear what you said.
You didn't repeat it, then you didn't.
I'm sorry. Seriously, if you did say that, I did not hear you. Okay, so it can't equal 0, so we've got to make that x can't equal 2, just like John said. So the domain you can write like John wrote are all the real values. R stands for real values except, and this should be -2. Or you can write it like this. Okay, this is called interval notation. And so either way is correct. Make sense? Okay, what about the domain here? What about domain here? What's the domain for this one? That's not the domain. Those are the
All real numbers.
asymptotes.
Except -1 and -2.
Okay, so that's what I got here. Same. Almost, John. Almost. Jenna, what you were typing something. What do you think? Samantha, you were typing. What do you think? The other guys are here, so I just talked to them. Anything but -2 and -1, exactly. And those are, again, we had a couple people say, we had a couple people here say, what are those called? What are those on the graph? They are the, okay, good. So now let's get more specific. What kind of asymptotes? Vertical or horizontal?
Vertical.
Vertical. Okay, so this is good. What Jenna wrote is good, and what some of these guys over here were saying is good. And those are called vertical asymptotes. So
Vertical totes.
denominator can't equal 0, so we're going to set each factor equal to 0, and then again this is
What does that mean?
this is just interval notation. This says, okay, we're going from -infinity up to -2, and then all those numbers in between, all those little decimals in between, union -2 to -1, again union -1 to infinity. All right, again this is interval notation, and what Jenna wrote over here is just, I don't know what it's called. There is a name for it, but I can't remember.
Excluded
I know.
values.
Excluded values, I like that. That's not the technical name, but I don't remember. All right, let's go right here. Find the domain. What's the domain for this one, guys?
Chicken. It's
Huh?
the square root of -1.
What if you have a -1 and you square it? What do you get?
1.
1. Okay, and Jordan is saying, what'd you say, Jordan?
The square root of -1.
Saying square root of -1. Please remember, guys, that when you square a negative number, you get a positive number. Okay, Jordan says the square root of -1. Again, take that denominator and set it equal to 0, right? And when you set it equal to 0, solve for x.
That's right.
It should be the square root of -1. Okay, actually, what is the square root of -1? Oh my gosh.
1.
Whoa, come on, guys. Square root of -1. We did this before.
What? -1. Square root of -1 is.
John wrote it. It's I. Remember, it's that imaginary number.
That's not.
Excellent. And so the domain goes from infinity to positive, -infinity to positive infinity. Okay, vertical asymptotes. The domain is undefined. So whatever graph you have, it's like a brick wall. The graph goes up to it, gets really, really close, but it can't break through. Does that make sense? Those are what asymptotes, that's a good, I don't know, it's always what I thought of an asymptote. So, where's my vertical asymptote here?
X -2.
Okay, I got one person's answer. Anybody else? Jenna's answer. Anybody else? -2. Okay, we got a bunch of -2s, and that's correct. All right, what about here? Where are my vertical asymptotes?
All real numbers except for -1 and -2.
Okay. So I got one answer over here. All I want are the vertical asymptotes. Okay, Jenna, just the vertical asymptotes. John has an answer. All right. So they are -1 and -2. Last one. Where's the vertical asymptote here?
Square root of x. Is it I?
What kind of number is I? Imaginary. So,
So
it's just not real.
is it ix?
There isn't any. Okay? Because, again, I is where an asymptote would be, but it's an imaginary number. Okay? It's just not real. Okay. So if I were to graph this, again, we would have a vertical asymptote at -2 and a horizontal asymptote at 0. And remember, okay, the other thing to remember is vertical asymptotes are equations, and that's why it's x is equal to -2. Horizontal asymptotes are also equations. All right, this is something that we'll talk about a little bit later, and as the function approaches -infinity or positive infinity, x approaches that vertical asymptote. We're not really going to go into that too much. All right, so for this, again, the assignment 2, you're asked to do a few numbers, a table, a little bit of a table. You're asked to draw in your asymptotes and then hit a table. So here's a little bit of a table for you. That'll help you both on the right side and the left side. Well, I did that wrong. This is the left side. This is the right side. Okay, I just said the same thing twice. Anyway, you know what I'm talking about, left and right. These will help you. You're going to need a couple tables. Okay? Make sense? Not every number, no. Just a few numbers, Samantha. Just pick out a few numbers. Okay? All right. And I think we're just about done. All right. I think we're going to have to quit because it's been 30 minutes and I really don't like to go, sit down. Don't like to go over 30 minutes. All right. All right, guys. So we talked about vertical asymptotes and horizontal asymptotes, and we talked about transformations, and that's basically what assignment 2 is about. So does anybody have any questions?
Nope.
Anybody here? Anybody here? Okay, I'm going to say nobody has any questions here because nobody's answering. All right. You have to stay. No. All right, guys. You are free to go. Thank you so much for coming. If you were here and you actually participated, please put attended in the webinar. And I don't think it's in there yet, so I'll put it in there when I get done. All right? All righty, guys. Have a great week.